Hello, dear students. Let us do a simple problem on air refrigeration system. So, let us consider a simple problem. In an open type of air refrigeration installation, 1,000 kilogram of atmospheric air is circulated per hour. The air is drawn from the cold chamber at 7 degrees Celsius and 1 kilogram per centimeter square, and then compressed isentropically to 5 kilogram per centimeter square. It is cooled at this pressure to 27 degrees Celsius and then expanded isentropically down to atmospheric pressure and discharged to the cold chamber. Point 1. Heat extracted from the cold chamber per hour. 2. Heat rejected to the cooling water per hour. 3. COP of the system. Take gamma of air. Gamma means the ratio of specific heat constants of air as 1.4, and CP value here it is given 0.24 kilocalories per kilogram degree Celsius. So here the unit of CP is not in SI unit, but it is in CGS units. So we need to take care. Okay. So here now again let us read this question once more. In an open type of refrigeration installation, okay, it is they are talking about a refrigeration system. 1,000 kilogram of atmospheric air is circulated per hour. Okay, so and again they are saying the air is drawn from the cold chamber at 7 degrees Celsius, like that. So here it is very clear that here the working fluid is nothing but the atmospheric air. So we have already studied a refrigeration system with working fluid as air, which is nothing but our air refrigeration system, or in other terms, reversed Joule cycle or Bell-Coleman cycle. Okay, so straight away let us try to draw the PV diagram and TS diagram of this air refrigeration system. So okay, so let us draw the PV diagram first. First of all, you should start with the refrigeration step, that is constant pressure heat absorption step, that is 4 to 1. Then you draw the isentropic compression, the compression step, that is 1 to 2 process. Then 2 to 3 is the constant pressure heat rejection step, 2 to 3. Then 3 to 4 it is our expansion process. If it can be isentropic or polytropic also, that is the compression process can be isentropic or polytropic also. Okay, so 3 to 4 it is the expansion process. So we are getting the final cycle as 4, 1, 2, 3, and 4. Similarly, we can draw the TS diagram also. That is 4 to 1. It is the constant pressure heat absorption process. So you can first of all draw a constant pressure line. It will be a curve on a TS diagram. So mark 4 and 1 there on that constant pressure line. So 4 to 1 is our constant pressure heat absorption process. 1 to 2 it is our isentropic compression process. Okay, can be sometimes polytropic also. Then 2 to 3 is the again constant pressure line, constant pressure heat rejection process. Then for 3 to 4 it is our expansion process. About 1,000 kilogram of atmospheric air is circulated per hour. What does that mean? They are talking about the mass flow rate, or 1,000 kilogram of atmospheric air is circulated per hour. 1,000 kilogram per hour. So it is they are talking about a flow rate. Okay, the flow rate of what? 1,000 kilogram. It is mass. So it is mass flow rate of atmospheric air. So we can first of all note that mass flow rate of atmospheric air, we can take it as 1,000 kilogram per hour. Okay, so again, air is, again we are continuing reading the question. The air is drawn from the cold chamber. The air is drawn from the cold chamber at 7 degrees Celsius. Okay, what is meant by this cold chamber? Cold chamber is nothing but the normal freezer compartment, or the area where we want the coolness to be produced. Normally, it is the freezer compartment. Okay, the air is drawn from the cold chamber at 7 degrees Celsius and 1 kilogram per centimeter square. So, what is this 1 kilogram per centimeter square? It is the pressure term. Okay, kilogram per centimeter square. That is per unit area. Okay, it is the pressure term. So they are talking about the temperature and pressure maintained inside the cold chamber. So now let us what. So where is the cold chamber here? It is the freezer compartment or the refrigeration step. That is during the process 4 to 1. So P4 and P1, P4 and P1 will be P4 and P1 will be 1 kilogram per centimeter square, and uh, the cold chamber, sometimes confusion can be there. That is, here it is given, the air is drawn from the cold chamber at 7 degrees Celsius. Okay, so there sometimes you may be getting confused whether it is T4 or T1, whether it is T4 or T1. How to find out that? So again, let us read the question continuously. The air is drawn from the cold chamber at 7 degrees Celsius and this much pressure, and then compressed isentropically, and then straight away compressed isentropically to a higher pressure, that is 5 kilogram per centimeter square. So now which will be our temperature? Okay, if they were talking about T4 as 7 degrees Celsius, the immediately after this point 4, it is our refrigeration step, not the compression process. But here in our question, they are talking that, they are telling that after taking the air from cold chamber at 7 degrees Celsius, it is straight away going for compression step. So what does that mean? They are talking about 7 degrees Celsius as the temperature at point 1. So air will be drawn from the cold chamber at point 1, and straight away go that air will be compressed from 1 to 2. So it means T1 is nothing but the 7 degree Celsius. So don't get confused between T1 and T4. So by reading the question fully, we can assign the value, of 7 degrees Celsius to T1. Okay, then we are again reading the question. It is compressed isentropically to 5 kilogram per centimeter square. So after compression, the the compressed pressure, or the pressure is increased to the final pressure, that is the higher pressure drawn over here, that is P2 and P3. P2 and P3 will be that is here. We can note this down. P2 and P3 will be 5 kilogram per centimeter square. So again, we are reading the question. So it will be a very good practice. That is, first of all, read the question thoroughly, then try to extract the values given in the question. That is, we are slowly breaking down this very big question. Don't be afraid to read such a very big question. Usually the bigger questions will be the easier one to solve, because the bigger questions will be carrying more and more data, which will help us to solve the questions very easily. Okay, so read the questions fully from one end to another end. So whatever details are given in between, note down the values one by one. So the very big question will be becoming very simple to us. It will be, we can simplify the very big question like that. So again, we are continuing reading. It is then compressed isentropically to 5 kilogram per centimeter square. It is cooled at this pressure. Okay, again you note down, after compression, the pressure raised to 5 kilogram per centimeter square. it is cooled at this pressure, means it will be, this cooling down process is a constant pressure process, and it is cooled to 27 degrees Celsius, 27 degrees Celsius, and then expanded isentropically, like that. So, which will be this 27 degrees Celsius? Which will be this 27 degrees Celsius? That is after becoming this higher pressure, that is after attaining the higher pressure of 5 kilogram per centimeter square, that is P2 and P3, that is at point 2, it is cooled at a constant pressure, that is cooling down, that is the heat rejection happening, uh, heat rejection happening from 2 to 3, that is constant pressure heat rejection, it is cooled down to 27 degrees Celsius, means after this constant pressure heat rejection, the atmospheric air will be cooled down to T3, or T3 is nothing but 27 degrees Celsius. T3 will be nothing but 27 degree Celsius. So again, we are continuing reading our question. It is cooled to 27 degrees Celsius and then expanded isentropically down to atmospheric pressure. Okay, it is expanded down to atmospheric pressure. Okay, and uh, that is again, if we are looking down to our PV diagram, after the point 3, it is expanded isentropically down to the atmospheric pressure. So what will be the atmospheric pressure here? P4 or P1. But we have already written the value for P4 and P1. It is written like this: 1 kilogram per centimeter square. Normally, in if nothing else is mentioned, we can take the value of one atmospheric pressure as 1 kilogram per centimeter square. So P4, yeah, that is after expansion, it is brought down back to P4. Again, we are reading the question. It is expanded isentropically down to atmospheric pressure and again discharged to the cold chamber. Okay, that is clearly shown over here. That is after this expansion, the atmospheric air or the working fluid has reached the point 4. At point 4, it is admitted back to our cold chamber or the freezer compartment, where the atmospheric air will again take up heat and produce the refrigeration. Okay, so that is what is given in our question. So first of all, now let us try to read the question. Find one, heat extracted from the cold chamber per hour. Heat extracted from the cold chamber per hour, which means we have to find out the heat extracted from the cold chamber, which is the cold chamber 4 to 1 process. So we have to find out the heat extracted during the cold chamber process. So what kind of process is this 4 to 1? It is the constant pressure heat absorption process. Okay, so first of all, we have to find out the heat absorbed during 4 to 1 process. It will be a constant pressure heat addition process. It will be mcp delta t itself. Okay, so if you look at the TS diagram, 4 to 1, it is happening along the constant pressure line, that is P4 and P1, both are same, the constant pressures. Then mcp delta t heat will be absorbed during this process 4 to 1. Then T1, T1 we know, T1 we know, we have straight away it is given in the question, uh, that is 7 degree Celsius. But what is this T4? But what is this T4? T4 we have to find out. T4 is not given in the question. So how to find out this value of T4? So we can take the help of the process 3 to 4. Okay, that is the point 4 is common to the process 4 to 1, and it is also common to the process 3 to 4. During the process 4 to 1, heat is absorbed, but no much further details are given regarding this 4 to 1 process. So now let us look at the other process, that is 3 to 4. 3 to 4, in the question itself they are saying that it is a isentropic expansion process. 3 to 4 isentropic expansion process. So we can straight away apply our isentropic process or isentropic law to 3 to 4. So during the last derivation itself, we have seen how to apply this isentropic process to 3 to 4, and we have already derived this simple relation, that is P4 by P3 will be equal to T4 by T3 raised to gamma by gamma minus 1. Okay, so if we cannot remember this by heart, no, actually no, there is no need to remember this by heart. If you can apply this isentropic law, and you can derive this simple relationship in the exam hall itself, it is not much a big deal. So substituting all the known values, we can arrive at here t3 times 1 by 5 raised to gamma minus 1 by gamma will be equal to t4, and we can cross multiply, we can find the value of t4. Always remember, the temperature terms should be in Kelvin, that is SI units. Okay, so if we are going wrong here, that is T3. T3, it is given 27 degrees Celsius in the question. First of all, we have to convert it into Kelvin, and multiplying with the rest of the terms, we can arrive at here 189.4 Kelvin, which will be nothing but minus 83.59 degree Celsius. Then, so now T4 we have found out. So substituting the value of T4 here, so the QA or the heat absorbed during the cold chamber will be mCp delta T. M will be the mass flow rate, which will be nothing but 1000. Okay, 1000. Actually, if you can, if possible, you please look over here. I have written the units also here. Please take care of the units. This I am telling from the beginning itself. So 1000, the unit will be kilogram per hour times 0.24. 0.24 is the CP value. The unit itself is kilocalories per kilogram degree Celsius. Okay, then this is the temperature terms. Okay, actually they should be taken in Kelvin, but since this is a temperature difference happening here, there is so so here the because of this temperature difference taking here, we need not convert it into Kelvin. We can leave it as such in degree Celsius itself. So the final unit will also be in degree Celsius. Okay, so canceling out the common terms, we can finally arrive at the unit of the answer as kilocalories per hour. Actually, this canceling out of this units itself, it is not a proper way to carry out in an actual technical practice. But in order to make you understand how this final unit came, I just noted it. I have given it. I have given it here. Okay. So now let us continue with the rest of the question. Uh, so now we need to find out the heat rejected to the cooling water per hour. So where is this cooling water normally supplied? At the at the cooler. Okay, or the heat rejection process. The atmospheric air after absorbing heat, the atmospheric air after absorbing heat, it will be rejecting the heat to a cooling water circuit during 2 to 3 process. So they are talking about the cooling water circuit maintained between 2 to 3. So here they are asking us to find out the heat rejected to the cooling water per hour. So here now let us try to solve that also. So here 2 to 3 process, it is a constant pressure heat rejection process happening. So the heat getting rejected during 2 to 3 will be mCp times T2 minus T3. Okay, so again we can apply our uh, here T3 is known. So T3 value is known as 27 degrees Celsius. Okay, but how to find out this T2? T2, how to find out? Again, just like we found out, um, just like we found out T4 by considering the isentropic process 3 to 4, here we can find out, here we can find out the value of T2 by considering this 1 to 2 process as the isentropic process. So applying the isentropic law, isentropic expression to 1 to 2, in the previous derivation itself we have discussed this. T2 by T1 will be equal to P2 by P1 raised to gamma minus 1 by gamma. So substituting all the known values, T2 will be finally becoming equal to 443.46 Kelvin, or it will be 170.46 degree Celsius. Okay, so here also don't forget to take the SI units for the values. Okay, then, so the heat rejected will be 1000 times 0.24 times 170.46 minus 27. The final value will be in kilocalories per hour. Okay, so the final step in our question, it is they are asking us to find out the COP of the system. How to find out the COP of the system? In the question itself, they are saying the compression is happening isentropically, and the expansion is also happening isentropically. So how to carry out this? Finally, COP will be equal to T1 by T2 minus T1. Why? Because in the question itself they are telling both compression and expansion are happening as isentropic. Okay, so we can just substitute our values for T1 and T2 here in Kelvin terms or SI units terms, and finally the COP value is found out as 1.71. Okay, so that is the final answer. So now we have solved our entire problem. Thank you.